if you build the change, it will last the test of time. So when we say it out loud, what we're really saying is that you should be building your systems about as agnostic as possible. But if you're doing it for churn, it's like, I have this new standard, and now this new standard doesn't gel well with anything that I have going on in this back end. So now you're churning, you're literally building, doing, changing your application to now be able to fit this standard that came out of nowhere.
Hey everyone, welcome to another Hatchpad Insight. I'm Lauren Alexander, one of the creators of Hatchpad, the career hub connecting technologists with emerging startups. If it's your first time here, don't forget to hit subscribe for more insights like this one. Today, we're here with Emmanuel Iroanya, the founder of Theta. During this interview, Emmanuel discusses why it's more important for engineers to focus on building a product that can change rather than one that lasts. Let's dive in. Kind of the first question I wanted to ask you. Your team over time has developed a mantra. Basically, you all will remind yourselves to build it to change, not to last. So could you speak to us a little bit about what that means, what that looks like for you all?
So it's funny. It's one of those sayings that we say internally and people hear it and they love it. And when I explained it, they was like, I get it. Because we always say internally, build it to change, not to last. But if you really think about it, if you build it to change, it will last the test of time. So when we say it out loud, what we're really saying is that you should be building your systems about as agnostic as possible. Any application you build should try to be as technology agnostic as possible, because at that point, you're not dependent on a framework or a specific set of libraries that if they're deprecated, that your whole application is messed up or is no longer a thing that you're spending development time to make better. You're spending development time to just keep alive. So when we really say build it to change, not to last, overarchingly, we're saying, hey, build it as agnostic as possible. And then, when it gets down into the weeds, we can start, we start like giving examples of what that means, or start like giving descriptions of how you could do that. But yeah, it really just means to build agnostic and when you break it down to its core.
Awesome. So then I know something that's pretty common these days is that in the education process for those who are going through and becoming an engineer, a lot of times there's more of a focus on tools and frameworks and making sure you really know about the different programming languages out there. But there's sometimes not as much of an emphasis on how to actually build software. So can you talk a little bit about that trend that you might have seen, and why do you consider that to be a problem?
Woo, how much time do you have? So, and I don't want to speak like I'm some, sage, wise man that's been here forever. I'm 33. But at the same time, I have had the ability to really take to my technical education and the things I've been well at, more on the operations and operating system side of things. So it's a lot of systems type of projects. And I think that, to answer your question, a lot of people are, like you said, learning development tools or learning tools and not really learning the fundamentals of, what it means to build a software application. Because learning the newest program, like for instance, JavaScript, a lot of the JavaScript frameworks specifically are ones that everyone's coming in and learning right now. There's nothing wrong with that. A lot of jobs will be digital. Getting them in here is very important, but at the same time, treating these applications and following more of a software tools philosophy helps you learn how to actually build software first and then applications after. And that's something we're trying to really drive home, because we follow a Unix philosophy that sort of was a software tools philosophy where I had a need of something to do a thing, not necessarily to be a thing. The distinction, while it sounds, it's not that different, like there is a nuance to it, and really driving that through, I think really would help, people learn and understand more, when you're building a tool, how many other things have to go into that tool rather than just, hey, I'm just building a thing that has to be a thing. It's I don't know, it's just hard to explain, but, people that hear this will understand hopefully what I mean and understand my heart and thoughts, what I'm trying to say. Yeah.
Yeah, definitely. So then could you hit on that just a little bit further? Why is it so important to focus on resiliency and portability with, whatever it is that you might be building?
It's interesting. Like for instance, what we internally at Theta, we have a innovation lab. We call it our R&D as a service type of wing of the company. And in that wing, we are constantly just thinking about, okay, how we love this, we want to build a change, we want to do it, how do we do that? And I think specifically with this project, Brick Frog, this edge collection platform that we're working on internally, that we think has a lot of play for a lot of uses in a lot of industries as we're building this digital world around us. One of the things that we were thinking about, how do we make this so that this does last, but it is adaptable, it is agnostic, and a lot of it comes from just how we chose to build this rather than going with a framework. We decided, hey, let's go with a language that's as close to C as possible, that we don't have to worry about something changing and then we're screwed. I don't know how many people listen, but think about how many Python 3 or PHP. I think about people that got to go from PHP 3 to PHP 4. I mean, they were losing their minds having to rewrite things, and we're thinking like, hey, how do we stop that by going things that go as close to C as possible? For instance, we build things, we're betting at the company on Go right now for reasons that, we believe that it is C-like programming language for applications that allows us to, like you said, build the change. Because once you've compiled a Go program, that binary is itself. That is, there's no other things you have to do to make it work. It's ready to go at that point. And any things you want to do to it could be attachments, or you can always know that this will cross compile, it's portable, it will be able to compile on any hardware. I could go grab a old laptop from whenever and get started. Like that type of portability is so important when you're trying to build tech that works for everybody, especially if you're trying to build products and tools like we're looking at data that essentially will be invisible to a lot of people, but will really be helping a lot of people. So being able to go as far back and be able to be in the middle of the old and the new, and be able to then adapt with the new while always bringing the old along, that is a novel concept. For some reason has been lost, but that's really all we're doing. All we're saying we're building change. How do you get to the middle and bring everyone along at the same time?
Very helpful. So you've also shared that it's important to focus on building the software first before you lock into a particular framework. Could you give some examples of how your team actually does that? Talk us through that a little bit.
I don't know, people are gonna look at this weird, but like for us, like a lot of frameworks that people are using, rather than build them, we sort of just build our own. That's what you look at a lot of people's frameworks. How much of those frameworks are you actually using? You probably went in there for like 4 or 5 specific things, and then you're bringing a lot of bloat with you with your application because you wanted to use something. If you're picking, like I remember in our first article with Technical Debt, one of the things we said is like, pick something pick something so well that all the stupidness that comes with it and all the great with it, so you can mitigate with people, but do all the really great things you want to do. So there you can build a framework or build your own framework so that you don't have to bring the bloat around. So that's what we do. Like for instance, our edge collection platform, we really started thinking about some of the things we could do and say, for what we need to do with this, why not just write it ourselves? I don't want to get too much into the weeds, but like the one part that we looked at that this could be a framework just to read off of these many meters of different IoT devices it wasn't worth the hassle. It just wasn't worth the hassle when you do it yourself. And when you do it yourself with a program language that you understand or that is portable, like how we're building it with Go, it makes sense that way. So I won't say that we're some gurus, but really realizing what you need from a framework and trying to either strip it or implement it, just those pieces yourself, gives you more control and allows you to be more portable at the end of the day if you're making the right decisions when you start building the tool or application you're building. So yeah, that's sort of how we go about it.
Definitely 2 really helpful approaches. Are there any other tips that you might recommend to developers if they're trying to get in this mindset of let's build the software first, let's focus on that before we're locked into a particular framework?
Before you get locked in any framework, just pick something. I've been a few people that I know that have walked into projects and they're like, hey, we made a mess, we need you to clean it up. And it's like, okay, in that situation, I do believe that a proper postmortem of how we got there is useful, because then we can look at all the decisions that were made that are sort of making you do churn rather than change. And that's something we try to emphasize, is that, when you're building the change or doing it right or putting all the thought in the beginning of the process before you even put line to code, is that you should be thinking about how your software is going to help you and how your software will change with you, rather than how it'll be just churning along. And so change versus churn is big. And for change, it's like, hey, if you're working on a software to make it better, make it more useful, make it more feasible, then that's when you're actually, built a product that's going to change. It's agnostic. It's going to see, hey, in 2025, this new piece of really cool tech can talk to this agnostic tool we built. Whereas if you're just building churn, like I said, that's where you're spending all the time as a developer, just trying to keep this thing alive. You're a slave to limitation. Whatever happens here, this change happens, and then I'm stuck. Trying to keep my app running, keep my app working. It's one of those things that you can say it a million times, but you got to actually catch it. You got to be able to catch it. And so getting in there, really going to the genesis of how you got to where you are, really understanding the decisions and seeing where you can refactor those bad decisions, or how you can start ripping out those bad decisions to make your product more agnostic. That is turning the churn into change, so that the application continue to get better over time, and you can do more, and it can change, and it'll technically last while also being able to change. And so it's one of those nuanced things. But really, that's the mindset you got to be like, hey, how did I make the decision? How far away is this from being portable? If so, how can I make this portable? What parts can I refactor? And then from there, your application start going towards change rather than churn. So that's one thing we emphasize, is the difference between change versus churn. And any developer that can get into that mindset, I think, will be able to really make some really cool software tools that then can be built as building blocks for really cool applications, if that makes sense.
Yeah, definitely. So before we move on from that, could you just take a step back real quick and just explain briefly what you mean when you say change versus churn?
When you're working on software to make it better and make it more feasible, you really are making applications change. Like if I come in and say, this new standard is the new standard for building software, and my application is as agnostic as built as agnostically as possible, then, hey, picking this new standard and making that standard applicable to my application isn't that big a deal. But if you're doing it for churn, it's like, hey, I have this new standard, and now this new standard doesn't gel well with anything that I have going on in this back end. So now you're churning, you're literally changing your application to now be able to fit this standard that came out of nowhere. When if you had built your application to change and built it about as agnostic as possible, this standard, like, oh, who gives a shit? We're adding a couple 100 lines of code here to do X, Y, and Z, and then you move on with life, because you're constantly moving forward, incrementally moving forward. You can't incrementally move forward if you're, constantly just doing one step forward and then 30 steps backwards because you picked the wrong thing to begin with at the genesis. So that's really the difference you change versus churn.
That's honestly super helpful. Yeah. Just to be able to kind of clarify that. Yeah, that's great.
Yeah.
So good. So then, okay, I want to take a step back here. You were talking about making sure you really understand the concepts of a framework before you lock into that. So I am curious, could you give any tips for a team of engineers that may not be able to build their own framework or may not choose to at this time? So they are going to choose an existing framework. If it's a framework that's new to you, how do you make sure you really have a good grasp of this before you choose that one?
I don't want anyone to come off this and say, hey, he's anti-framework, because that's not true. There are parts and points where using a framework makes sense, like in the front end. It makes sense there. That's where a lot of your change is going to happen, in that front end anyway. So at that point, that's sort of all you have. JavaScript is all we have right now until WebAssembly gets there for everyone. So you have JavaScript. So certain frameworks, that makes sense in the front end. But my problem is like when you have frameworks in the back end doing all the heavy lifting, and then you're like, well, shit, this changed, now I'm screwed. So for me, if you don't understand a framework, that's fine. At that point, my idea, what we tend to do is try to decouple as much as you can. Like I said, a front end framework, cool. You throw Angular on the front end, you use that framework, that's not a problem. But on the back end, if you're building this to change, then you're building this about as modular as possible. So you're building little engines, little services that do X, Y, and Z, and that you don't need a framework for. That's really building your own services. This goes back to that software tool philosophy, that unit philosophy of doing one thing, doing it well, building your own alphabet, A through Z, so that you can go write your own Shakespeare or your own play at that point. So that's really how you should be looking at software. But you're seeing people taking things and saying, hey, I'm going to use this framework to do all my heavy lifting for things that aren't that heavy to begin with, and then you're sort of screwed. And that's my beef. I just want people trapped in these frameworks because there's no way for us to move forward if we're all trapped just churning along with the same framework, trying to make something that didn't work to begin with work. You know what I mean? But again, I'm not anti-framework. I'm anti-framework where they're not necessary. And that's the problem. That's why people are building things that are lasting. Because say, hey, if I build this framework now and use it here, I got a thing that does it. That's a thing, and people can start using it. But what is it supposed to do? Did it do that thing well? And can it do that thing in 20 years? If not, then you build something that lasts in this moment in time, and that's it. It doesn't come to 2022 with us. In December 31st, it's stuck. And that's not a useful application. You see what I'm saying? That's not a useful tool. It's not a useful piece of software. It's a waste of time. And so that's why I'm saying, like, just be careful, be mindful. If you're building to change, you're building software as a bunch of tools that, when put together, give you an application. You see that does a thing. So that's my thing. To couple as much as you can, use frameworks where it makes sense. And that's how you're building to change, not to last. That's really the concept. Pick a software language that is as portable as possible, that can go as far back as possible, but still get you to the new world. And that's why, like I said, we're betting on a language like Go.
Along that vein, I'm curious, with this idea of a portable language, what are some indicators to your team that the language that you're considering would be portable and would be a good option?
How many abstraction layers away from bare metal are you? Is the first thing we're looking at. And then from there, we start making decisions from there internally. But yeah, that's really what we're doing, is how far from bare metal are you? And what is the hassle of every layer going further away from bare metal are we inheriting, and can we deal with this? And then that's when you start to realize, okay, this is portable, because this at the end of the day will have to be here on any system in order to run. So that's what we're doing. How far from bare metal can we get and still be able to build something that is useful to the majority and not a few hardware engineering dudes that really set pretty much what we do in the application world, but we don't think about it that way. So, outside of Rust, you're not really seeing too many things that have came in and say, hey, I'm going to replace C. It is the only time I look at it and say, that is a static language. Go to us is sort of like a static language. We're seeing a lot of similarities. So that's why I'm willing to bet on it. And that's why I'm looking at how far from C can I go and still be as static or agnostic as possible for what we're trying to build. And that's what we're doing.
So an aspect that I know can come in for a lot of teams when they're making a choice is that sometimes there are certain frameworks or languages that folks just prefer. Maybe it's because they're familiar with it. Maybe it's because they've dabbled with it a little bit and they want to use it some more. So are there ever times when it's worth choosing a framework or language just because developers on the team are kind of attached to it?
Sure. Like I said, front end, of course, all day, every day, pick one that you're familiar with. Like I said, I'm big on Angular, but still, that aside, content management systems. Who wants to go rebuild their own content management system? That's silly. Drupal's right there. And Drupal got the idea to decouple much further ahead than everyone else. That makes sense. That was one time where that makes sense, because when I'm really looking at what I need to do, why not? It's just content I need to get in the public facing arena for people to see. It's just like, hey, I want to build a thing that's never been done before. Let me go grab a framework that did something else and make it work my way. You're inheriting a lot of mess for no reason. You see what I'm saying? That is really my beef. And I'm seeing people do it all the time, where you could have spent a little bit more extra time if you went to school and took a comp sci class. You learned at least enough languages that there's enough understanding of the bad and good of this language to at least say, okay, let me use this as a baseline to figure out what really makes sense for what I'm going to do.
Very helpful. So as we are wrapping up, I'd love to hear if there are just any last tips that you would give to developers who want to incorporate this mindset of build it to change, not to last.
Every developer should do a tour and operations first. They will think about it a little bit differently, I promise you. Every developer needs to do a tour and operations. And to be fair, every operations person should, at the bare minimum, be able to do a very brief stint in developer land. Because when you understand each person's constraints, you tend to be more cognizant of what you're doing, you know, and you tend to be more cognizant of your choices and the impact of your choices. The point is, no matter what, you have to be able to do a tour and operations, even for weeks, to understand the constraints of what they got going on, and vice versa. You know, make everyone be a better technologist, regardless of your title, because we're all technologists at the end of the day, and we're all just trying to build and promote and get this technology and tech as far to the future as possible together. And so doing it together means understanding what other people are going through. So that's my biggest thing. You know, everyone just had a little bit more empathy in how they build software by, you know, being a part of other things. We build better software. I promise you.
That's fantastic. Love that. You know, those are all the questions I wanted to run through with you today. Do you have any last things you'd want to share with people on this subject?
If I was saying anyone, if you want to talk about more, if you're just interested, you know, there's ways to find me on like Twitter and things like that. Like these are conversations like on my LinkedIn. Like I really like talking about Linux and like hardware and IoT and edge computing and invisible computing. All these things I'm saying, talking about things I actually like for fun, just read up on and want to know and try to implement and how we build software here. So I would just say find me on Twitter. And we can have conversations all day, every day about this. It's something that's really passionate. I'm really interested about, and I hope that other people hear this and say, "Hey, I hear what he's saying there, but maybe he missed something here." Because I want to learn. Like we are on this planet to learn. So if there's someone who could teach me something new about my opinion, or help me see a different way to better describe my opinion,
sure,
I'm game. So yeah, like this is what we're here for. This is why these type of interviews, and that's what they're here for. You know, so we can all learn a little bit more and grow.